Composition of functions. So composition of functions, the big idea here is that we're plugging one function into another function. The composite function is defined in this way. The way we read this out loud is f composed with g of x. That's how you read this portion. Let me write that. F composed with g of x is the same thing as taking the function g and plugging it into the function f. This is plugging function g into function f. When you look at f of g of x, which is obviously the nicer way to look at it, this notation is a little bit weird. This is an open circle, and I know it looks like multiplication, and I want to point out really quickly that this is not multiplication. I'm going to make a note, not multiplication. This is not saying to multiply f and g together. This is the symbol for composition. It's an open circle. It is used to mean composition. Obviously, this notation is a lot less nice and a lot less straightforward than writing it like this. This makes a lot more sense because this is telling us, hey, you have an inside function that we're plugging in to another function. So g is the inner or inside function. And we call f the outside function or the outer function. So let's do a few examples here. We're given two functions, f of x equals x squared plus 1 and g of x equals 2x minus 3, and we are going to compute a few different compositions. So here, f composed with g of x, that's the same thing as f of g of x. And let me do a little bit of highlighting here. So our function g of x we are replacing with 2x minus 3. Instead of g of x, we are writing 2x minus 3. I'm now taking 2x minus 3 and plugging it in for x in this function x squared plus 1. So originally, this function f would have been x squared plus 1, but now, instead of x, let me move it a little bit different, move it like, boo. Instead of just x, we have 2x minus 3. So we're taking the function f and we're plugging 2x minus 3 into it. If I FOIL out 2x minus 3 and add that plus 1 at the end, here's what we're going to get. We're going to get 4x squared. It's going to end up being minus 12x plus 9 plus 1. That's from FOILing and then adding the plus 1 at the end. 4x squared minus 12x plus 10. So we plugged g of x into the function f. We can go the reverse direction though, and we can plug the function f into the function g. So g composed with f of x is the same thing as g of f of x. F of x is x squared plus 1. So this is g of x squared plus 1. The function g was 2x minus 3, but instead of x, I'm putting in x squared plus 1. So we have 2 times x squared plus 1, that's this x right here, turns into x squared plus 1 minus 3. Distributing the 2, I get 2x squared plus 2 minus 3, simplifying 2x squared minus 1. So the compositions of f composed with g is not necessarily the same as g composed with f. I'm going to make a note somewhere here. In general, f composed with g of x is not equal to g composed with f of x. There are times where they are equal, but it is not a rule. They are not necessarily equal. These are two very different functions. We can compose a function with itself. So this is saying f of x, right? F of x is x squared plus 1. So now I'm taking x squared plus 1 and I'm plugging it into the function x squared plus 1, right? If we think of f as being f of whatever equals the whatever squared plus 1, what I'm doing is I'm putting x plus 1 into this square here. So this is going to be x squared plus 1 squared, right? This is being plugged into this box here, plus 1. This will be x squared plus 1 times x squared plus 1 plus 1. Foiling, we're going to get x to the 4th plus 2x squared plus 1 plus 1, x to the 4th plus 2x squared plus 2. Bam. For g composed with g, remember g of x is equal to 2x minus 3. 2x minus 3. So what I'm doing here is I'm taking g and plugging g into it. Let me just do this. I'll just do a highlight. So this becomes g of 2x minus 3. Again, much like with f, I could rewrite this as g of whatever is equal to 2 times whatever minus 3. I'm taking this 2x minus 3 and plugging it in for these places because g of 2x minus 3, the box is the 2x minus 3. This becomes 2, right? 2 times 2x minus 3 minus 3. Distributing, I get 4x minus 6 minus 3. That comes out to 4x minus 9, and that is G composed with G. Cool, fun stuff. Okay, so that's functions. Let's doing the composition without plugging in values. But we could go further than this, and we can plug in values. So let us look at this next one. So given the functions below, find f composed with g of 0 and g composed with f of 4. There are two different methods that you can take to solving this. I'm going to write out both methods for you, and you can decide which one you like the best. The first method is to find the composite function and then plug in x. So if I'm looking at f composed with g of 0, I would find f of g of x first. Ooh, what happened there? Then we'd plug in x equals 0. So I'm looking at finding f of g of x. G of x is 1 over x squared plus 9. So that's what I'm replacing on the inside. This is f of, boom, 1 over x squared plus 9. And I'm plugging that into this function over here. All right, this f of x function here. So I'm plugging where I see an x, I'm instead plugging in 1 over x squared plus 9. So this is the square root of 1 over x squared plus 9. Now that I have f of g of x, right, which I do, f of g of x is the square root of 1 over x squared plus 9, I can just plug in whatever value I want for x and find the composition. In particular, f of g of 0, which is this thing right here, f composed with g of 0, is equal to this thing, but plugging in 0 instead of x. So instead of a x down there, it's a 0. This simplifies down to the square root of 1/9, which is 1/3. So f composed with g of 0 is 1/3. And that is one way for us to find that value. So this is finding the composite function first, then plugging in x equals 0. I'm going to do it in the reverse direction. I'm going to do it in the reverse direction. I'm going to pause the recording so it doesn't take me forever to do it, and then I'll unpause it. All right, so here we go. For g composed with f of 4, I found g of f of x first, and then I plugged in x equals 4. So here is my process of finding g of f of x. I plugged the square root of x, which was our function f. Maybe I'll highlight it. I plugged the square root of x into the function 1 over x squared plus 9. If you square a square root, it just turns into an x. So g of f of x was 1 over x plus 9. If you then plug 4 into this function, which I did down here, you'll get 1 over 13. So that's our first method. That's one method. The other method is to just kind of like evaluate from the inside out. Evaluate the inside, then evaluate the outside. And honestly, this method is probably going to be the one you want to use. The one above, the first method, is great, especially if you're going to be evaluating several values. If you're going to be doing f composed with g of 0, f composed with g of 2, if you're going to be doing several of them that use f composed with g, it makes sense to find the composite function and then to plug in the x value. But if you're just finding a one-off, it's best to do method 2, which is evaluate the inside and then evaluate the outside. So for f composed with g of 0, the way that this would work, you would rewrite this as f composed with g of 0. And we would find g of 0. Where are these guys? Trying to remember what my functions are. Okay. Remembering that f of x is the square root of x and g of x is 1 over x squared plus 9. If I'm finding g of 0, that's plugging 0 into the function g. So this would be 1 over 0 squared plus 9. So that's 1/9. So I evaluated the inside, and now instead of g of 0, I'm going to put 1/9 there because g of 0 is 1/9. So I have f of 1/9. I'm taking 1/9 and I'm plugging it into the function f. So this is the square root of 1/9, which is 1/3. That's the same answer that we got right up here. So works. One more time, let's do it with g of f of 4. G composed with f of 4. The way this one would work, we're taking g of f of 4. F of 4 is plugging 4 into this function up here, the square root of x. So we have the square root of 4, which is 2. So we are replacing f of 4 with 2. This is now g of 2. G of 2 means plugging 2 into the function g. So this is 1 divided by 2 squared plus 9, which will come out to be 1 over 13, which is what we got before. So there you are, 2 different methods to do it. Either way will work. They're just 2 different methods. I'm going to do a few more examples here. I put some here. If you want to use this time to try these on your own, that would be a good opportunity to do it. For all of these ones, I'm going to use that last method. I'm going to use method 2. So I'm going to be plugging in the inside and then the outside. So f composed with g of 0, that's f of, let's do some highlighting here. Let's use different colors. I don't know, did I use green? Let's use purple and green. Perfect. So we have f composed with g of 0. G of 0 comes from plugging 0 into the function g. So that's 0 squared plus 1. That's just 1. So this is f of 1. F of 1 is plugging 1 into this function f of x. So that's 5 times 1 minus 4, which is 1. So f composed with g of 0 is 1. Make a rectangle. I'm going to pause the recording to do the remainder of these ones. It's just going to take too long to do it all on camera. I'll unpause to go over the answers, but this would be a good opportunity anyway for you to pause the video and try these out for yourself. So give it a go. I'll be back in what is instantaneous for you, but probably 5 minutes for me. All right, so I have finished up these compositions. Here with g composed with f of -1, I'm plugging -1 into the function f. That's this guy here. So 5 times -1, that'll be -5. -5 minus 4 is -9. I'm replacing f of -1 with -9, just a direct replacement. Then I'm plugging -9 into the function g. Coming up here, g is the function x squared plus 1. So I did 9 squared, or -9 squared, which is 81 plus 1, and get 82. Down here, found g of 0 first. G of 0, which we found over here, is 1. And then I'm taking 1 and plugging it back into the function g again. So again, function g, plugging in 1. 1 squared is 1, plus 1 is 2. So 2. G of 0 is 2. This guy here, plugging 0 into f. If you do that, you get -4. -4 plugged into f again. Again, plugging into f, that is. -4, 5 times -4 is -20. -20 minus 4 is -24. So f composed with f of 0 is -24. So that's how these ones work. Really, it's just the same type of evaluating function stuff you've been doing all along, just with some new fancy notation and a little bit of a few extra steps. If you have any questions, send me an email. Otherwise, I believe in you. I know you'll be able to do this. Believe in yourself. All right. See you in another video. Bye.